Good morning. This is Dr. R. Subramanian from the Department of Physics, KPR Institute of Engineering and Technology. I am here to share about the insights of engineering physics course. As far as engineering physics course is concerned in KPR IT, we are having 5 units. Unit 1 deals with the lasers. Fiber optics is the unit 2. And unit 3 deals with the ultrasonics. Whereas unit 4 is concerned about the thermal physics and properties of fluids. And crystal physics is the content that we are having as unit number 5. So in unit 1, laser, the contents are given as laser characteristics, which deals with the spontaneous and stimulated emission and the different types of pumping methods that are available for the laser. And the particular laser, that is carbon dioxide laser, is given there. And one more laser, semiconductor laser, is given there. And how the materials are going to process using the help of laser. And also the application part, the selective laser sintering, hologram, and medical applications of lasers. These are the contents of unit 1. Before going into the theory content, these are the some applications of laser. So in the first figure, you will be seeing some laser burners, and in the second, you are having a laser engraving picture where the laser engraving letters has been engraved using lasers. And in the third, we all know that lasers are widely applied in dentistry and also eye surgery, and lasers are used to focus a particular spot in our tissue. And also lasers is the main component in satellite communication purposes and also in military purposes. So these are the basic characteristics of laser. As of laser is concerned, when compared with the ordinary light, the major keynote points or keynote characteristics of laser are directionality, its intensity, and monochromatic and coherent property. So as of the property is concerned, the directionality plays a major role. So we are comparing the directionality property in ordinary light as well as laser light. So as you all know that ordinary light spreads in all direction, whereas laser is highly directional. The angular speed of ordinary light is 1 meter per meter, whereas the angular speed of laser light is 1 millimeter per meter. So the directionality property is very high in laser when compared to the ordinary light. As far as intensity is concerned, ordinary light is spreads in all directions, and whereas the intensity of the laser beam reaching the target is very high. It's a single point beam, and also the intensity of reaching the target is very less in ordinary light when compared to the laser light. For example, 1 milliwatt power of helium neon laser appears to be brighter than the sunlight. And also the monochromatic property is concerned, in ordinary light, like a mercury vapor lamp, many wavelengths of light are emitted, whereas laser beam is highly monochromatic, that is the wavelength is single. This is clearly visible in the diagram. Whereas the white light source emits as many wavelengths of the light, whereas the laser light source emits a single wavelength, that is a green color. The only green color is emitted from the laser light source. Coherence is one more important property as of laser characteristics is concerned. The wave trains are of same frequency and also in phase with each other. That means the radiation is in mutual agreement, not only in phase but also in direction of emission and polarization. So it is a coherent beam. Due to the high coherence, it results in extremely high power. So the high power of the laser is contributed by its coherent property. So this is also evident in the diagram and is evident clearly. The first figure is dealing with the incoherent light waves, whereas the phase are different. Whereas the second figure deals with the coherent light waves, whereas all the waves are in phase with each other. So as of laser is concerned, the word laser deals with the light amplification by stimulated emission of radiation. This is the abbreviation of the laser, and it is a powerful monochromatic collimated beam of light which is produced with the device. It is coherent in nature. So we all know that laser light is coherent, whereas the LED light is an ordinary source of light which is incoherent in nature. So it was discovered by 1960 by T.H. Maimon. Rigorous analysis has been made in many types of lasers in the various form of solid, liquids, and gases. So laser is a light beam of frequency 10 to the power 14 hertz. So as we all know that we have already seen in the earlier slides, the properties of laser given in here: monochromatic, coherence, highly intense, and directional. So here the comparison is made with the ordinary light as well as laser light. So the first figure deals with the sunlight, which emits colors of different wavelength on multiple frequency, which are also non-coherent. And the second one is incandescent bulb, which is having single frequency, but it is non-coherent, whereas the laser light is single frequency and coherent. Both these characteristics are covered in laser light. And also regular light versus laser light is depicted here. Regular light has many colors or wavelength mixed together, creating white light. These light waves are spread out as they travel, whereas the laser light is of same wavelength with all the waves in phase and are in step with one another. A laser is always a single color because the waves are same length, because the wavelengths are parallel. A laser light stays in a light beam for long distances. So these are the differences between laser and ordinary light as of introduction part is concerned. So this is the summary of the introduction part. The angular spread is more in ordinary light, whereas it is less in laser beam. They are not directional, and whereas they are highly directional in laser beam. And also intensity is concerned, ordinary light is very less intense when compared to the laser beam. Ordinary light is not a coherent beam and is not in phase with each other, whereas laser beam is a coherent beam and is in phase with each other. The radiations are polychromatic, the radiations are monochromatic. Examples of ordinary light are sunlight, mercury vapor lamp, whereas the examples of laser beam are helium neon laser and carbon dioxide laser. Thank you.